So far, our scripts have just been a simple list of commands, and there's reason enough for that kind of scripting. You can automate what would otherwise be a repetitive bunch of typing, avoiding possible mistakes each time you type, and frankly it's faster than typing. But when you run the commands one at a time by yourself, you're getting feedback. Did the command succeed? And you'll alter your behavior before you proceed with the next command. But once you put those commands in a script and invoke the script, you start that script up, those commands are off and running. So let's look at an example of just how dangerous it might be and some controls that Bash gives us to prevent some of these potential disasters. Let's say I had some scratch files out on /temp. Now, of course, the name of the directory is /tmp. Let's say I'm writing my script. Well, by hand, if I were to just say cd to /temp, but I spelled it wrong, I'd notice right away I'd done that, and I wouldn't proceed with the next command. But what if that was in a script? Instead of /temp, let's say I misspell it, and then I go ahead and want to remove my scratch files out there. Later we'll see other ways to add variables to the script, and you'll need to do this kind of checking. It wouldn't just be for typos. But for now, let's just take the simple case of a typo. I'm going to cd to the temp directory and I'm going to remove it. So what happens if I run this script? I have some files here in this directory, but there's things in /temp I want to remove. If I run this script, I get the error message, but it didn't change the directory because the directory name was in error, so it stayed where it was, then proceeded to the next line and removed all my files. Not a good thing. Bash does have a real if statement that we can use to check and see if commands succeed, but it has a shorthand notation as well, something called control operators. It uses the and or operators that you might be familiar with from C language, Java, or other languages. Let's take a look at how that might work. First we'll go into a directory where I haven't destroyed all the files. And there we'll create a new script, our cleanup script, and it will say let's cd to /temp, and if that command succeeds, then we'll give it another command. Okay, instead of doing the two commands on a line by themselves, I join the two commands together with the double ampersand. That says if the first command succeeds, then do the second command. In a similar fashion, there's an or operator that lets us say if the command fails, then we want to take a particular action. But let's consider the and case to begin with. If I run this now, notice I get the same error message from the CD failing, but my files are left intact because it didn't execute the rm command. So what's going on there? Why the double ampersand? Well, remember your logic. Let's say you decide, if it's a sunny day and it's warm enough, then I'll ride my bicycle. If you look out the window and you see that it's raining, there's no need to check the temperature to see just how warm it is or isn't outside. If it's sunny and it's warm, then I'm going to ride my bicycle. That says if I check the first condition and it fails, there's no need to check the second condition. And that's what's happened with our bash script. If the CD succeeds, only then will we proceed with the remove. The examples we've used so far have all just used a single step if the condition succeeds or if the condition fails. But with bash, we're not limited to a single action. So next we'll take a look at ways to do multiple steps with these and or control operators. We looked at the and the or operators and saw how, in the case here of the and, if this command, first command, in this case the cd to /temp, succeeds, only then will it run the second command on that line, the rm. There was a similar, though logically flipped, logically opposite version of the or command, where we can say if the command fails, then it will run what's on the right here. And so we could print an error message out and say something like that the CD failed. And let's give that a run. We'll add one more line here of echo just to say notice we get the error message. We then get our own error message that says that the CD failed, but notice also it says the script is continuing on. That is, we've only been able to print out an error message, but we haven't been able to alter the program. Now what we could do is we could at this point just say echo or exit. And now if we run the script, we get the error message and it stops. Notice we don't get the continuing on message. But if you had done something like thrown away the error message because you don't particularly want to see it, you just want the script to behave, do what it's doing. Let's try that. We don't see any error message at all. It has just exited. So it might be nice to have some error message here. We saw before we could separate commands with a semicolon, but this is not going to do what you think it would do. Rather, when we run it, it gets the error message and then exits. But even in the case where it succeeded, let's correct that directory name and run it again. It too exited. Notice we didn't get the error message, but neither did we get the continuing on message. Why is that? Well, that's because that semicolon is a separator between statements, and it's much like if the command existed just on the next line. It's sort of a synonym for the new line. That separator there. So, and you can see in this case, no matter whether the CD succeeds or fails, the very next thing it'll do is exit, and you'll never get to that statement. So what we need is some way here to group these commands to the right of the OR control list operator, and we can do that with the curly braces. We need a semicolon on the end of that one, and this is just a little quirk in Bash's syntax, but you need the semicolon and a space and then that close right brace to get the syntax just right. So now what's going to happen is we'll do the CD, and if the CD fails, let's make the CD fail again by misspelling that name. If it fails, then it will need to check the other part of the OR condition, so it will then execute over on this side. It will echo that the CD has failed, and it will exit from the script. And we won't see this continuing on message. Sure enough, that's what happened. And just to check, we'll spell the name right. And we now get the continuing on message. So with an arrangement like this, we can check and see if this command succeeds. If it fails, we'll give an error message and exit. If it succeeds, we'll continue on with our script. So here it would be safe to do something like our rm star. There's another grouping command similar to the braces, but it's the parentheses. And in that case, what happens is these commands are run not in the current instance of the shell, but in a subshell. Now in this case, it wouldn't be what we want. What's going to happen is the subshell will get set up. In that subshell, the echo will run, and then the exit will run. It will exit from the subshell, but not from the main instance of the shell. And so in that case, even with the name misspelled here of our directory, we still get the continuing on message. Again, that's because the exit in this case was happening in the subshell of the parentheses, not in the main shell. So to do what we want, we need the braces, and then we'll get what we want. Now, what we've done here so far has been with these control operators. I think it's time that we take a look at the full-blown if statement in Bash. So far we've been looking at ways to modify the order of execution of a script without actually using an explicit if statement that you might recognize from other programming languages. Bash does have such a statement, and we can use that to great effect. Let's take a look at it in light of our previous script. Here we were doing a CD, and if that CD failed, and only in the case that it failed, did it continue on and do that list of statements over there to the right. So let's change that to an if statement and see what that would look like. In Bash, since the basic operation is executing statements, the if statement works that way as well. The condition here for if can simply be whether or not a command succeeded. And if a command succeeds, then we'll do some statements. Otherwise, as an else, we'll do some other statements. And then the fee ends it. Since it's a script, we can certainly indent. So we can have a true and a false result. That is, if the command succeeds, then execute a certain set of instructions. If the command fails, execute a different set of instructions. In fact, in this case now, we don't even need the braces, because inside of our else clause here, we can put multiple statements if we need. They could certainly have been left with the semicolon if we wanted, but this way each statement can have its own, a line on its own. So now you can see if the CD succeeds, then we'll echo this. Otherwise, if the CD fails, we'll echo a message that it has failed, and we'll exit from the script. And then on exiting the if statement, we'll continue on, and that message will come out. So let's give that a run just to see. Oh, and this is a misspelled /temp, so this should fail. And sure enough, it does. If we change the spelling so that it succeeds, that CD should work, and we run it again. There, we get the message that the CD command worked, and it continued on. let's review that again. The if statement has an if followed by a statement. If that command that follows succeeds, then the then clause, the else clause, and so on. These conditions, the else is optional. You don't need an else. Of course, you don't get what it does if you take the else away, but the else clause is optional. And notice the way I've got the spacing here. It is possible to combine all this on a single line using semicolons in the right place. It turns out that between the then and the next command you don't need any separator, but of course between commands we're going to need a separator here. So let's just join this all on one line and see what this looks like if we were going to combine this all together to pack it into one line. Here we need the semicolon to separate the if clause, if you will, from the beginning of the then statement. And similarly, we'll need a semicolon out here. And there. I'll get rid of this just so that you can see that it all fits on one line. So there's an if statement done all on one line. It usually is better to have it spaced out. It makes it much more readable. When writing scripts, it's better to use the white space. It's possible, however, to compact it all into one line if for some reason you need to do that. We mentioned here that the command is the determinant of whether the if is true or false. Let's look a little more closely at that. I'm going to break this up again into its components. And say that what we do here can be a single command, or it can be in fact multiple commands. We know how to do several commands inside of a list. For example, we could do something like that, and that's going to give us two commands in a list. And when you've got a combined list like that, the result of the if being true or false is whether or not the last command in the sequence succeeded. Similarly, we could take and do a pipeline of commands. We could run grep for some string and pipe that result into some other command. And if this final command succeeds, then the true branch will be taken, otherwise the else branch would be taken. So we can put multiple statements here in a sequence, in a list, in a pipeline, and it's the result of the last command as to whether or not it succeeds or fails. Next, we're going to take a look at sort of the logic of a return of a succeeding or failing command and how you determine that in a script. And after that, we'll proceed to a much more elaborate form of if expressions, where there's a whole lot more tests and a whole lot more evaluation that we can do, string comparisons, numerical evaluations, and so forth, beyond just simple commands. But first, let's take a look at that logic of what does it mean for a command to succeed? How do you make your script do that? And we'll cover that next. We've been looking at control statements, the if statement, and the conditional operators that control execution. And we've talked about whether or not a command succeeds or fails. And so we said here, if the result of this pipe succeeds, or we said if we did a cd to /temp, and if that succeeded, then the true branch would be taken, else the false branch would be taken. What is it that determines whether or not this command is deemed to succeed? Well, obviously there's the, did we get into that directory? But at a programming level, what's going on? And for that, we just need to look down here at the exit statement. When we exit from our script and we exit with a 1, we're exiting with a non-zero value, and in bash that means that the command failed. That if we want it to succeed, when a command succeeds, for example down here at the end of our script, we could exit with a 0, and that would indicate that this command, this script that we've just run, has succeeded. If we exit with a 1, that means the script has been considered a failed script. That is, a false branch should be taken on an if. So it's simply the exit value that determines whether or not a command succeeds or fails, and it's really up to the programmer of whatever piece of program, the command or whatever that you're running, to follow that convention. Keep in mind too that exiting that 0 as a succeed, as a true value for the if, an exit of 0 means that the if branch would be considered, the if condition would be considered true. That's kind of backwards from what you may be used to in other programming languages. Often it's if the result, if some number or some expression is non-zero, that's considered true and 0 is considered false. Well, in shell, it's the opposite of that, because I suppose for historical reasons, if it succeeds, there's just the one value that it succeeds, but you may want to return different values depending on the nature of the fail, depending on whether it was argument parsing or something else that caused a problem, and you can distinguish between various different kinds of exit values. So if a command succeeds, that is, if it returns 0, that'll be considered true. Now we get to take a look at one of the more powerful aspects of shell scripting, and that's going to be shell variables. We need to look at how you look at the result, the return value, the exit value of a script, but we'll open it up to the whole subject of shell variables in all their various forms. It's in a very powerful and much improved area in bash.